Welcome geometry students to class today on Thursday the 12th. Let's get started with some review material. Hopefully that will help you with your exam. Your exam will be next Friday on December 20th. My voice is a little raspy, so please allow me to clear my throat a lot, and I'll be drinking a lot of water. Your exam will be next Friday the 20th from 8:15 to 9:35. So that's when your exam will be. Test retakes, I'm going to go pretty fast today, guys. If I end up finishing before class is over, then count your blessings. I know it's just, I want to make sure I'm getting this video in. And by the way, let me jump down to announcement number 3. If I don't get this video in, you must finish it at your house. You must, okay? There's no, well, I'll do it tomorrow or Saturday. No, do it this evening, okay? So you don't get behind, so you know exactly what's going to be on your exam. Test retakes must be done by Friday, and you must notify me with at least a day's notice. When you notify me, you must tell me what day you're going to take the test and what teacher is going to give it to you, okay? At least a day's notice, test retakes by Friday. Now, let's quickly look at what we've learned, the review, the past couple of days. Definition of polygon, you must know that. You need to know these different sided polygons, 3-sided, 4-sided, 5-sided, 6-sided, 7-sided, and 8-sided. Know their names. You need to know the sum of the interior angles of a quadrilateral is 360. The legs of a trapezoid are supplementary, and what are the legs? They are the non-parallel sides. You need to know the base angles of an isosceles trapezoid are congruent. And what are the bases of a trapezoid? They're the parallel sides. You need to know in a parallelogram, opposite angles are congruent and consecutive angles, side-by-side angles, are supplementary. You need to know the 5 ways to prove that a quadrilateral is a parallelogram. You need to know the formula for the midsegment of a trapezoid, 2ms equals b subscript 1 plus b subscript 2. And you need to be very familiar with the 6 definitions of the 6 special quadrilaterals that we studied in this chapter. And here they are. Here's the 6 quadrilaterals right here. And then here's some details about them. Be very familiar with those. Okay? All right, moving on. Let's see here. You need to be able to look at patterns, figures, shapes, or numbers. Look at patterns of figures, shapes, and numbers and make a conjecture about what will come next. You need to be able to look at a statement and give a counterexample that proves the statement wrong. You need to be able to know what segments are, points are, planes are, collinear points, coplanar points, edges, sides, all of these things, and be able to answer questions about them. Okay? You need to know that when given segments, be able to add or subtract segments. When given angles, be able to add or subtract angles. And number 6, be able to give 3 names to one angle. That's what we looked at Tuesday. Now, yesterday, Wednesday, we looked at when given the midpoint of a segment, be able to find the length or the whole segment or 1/2 of the segments. In other words, if I give you a segment and I tell you this right here is the midpoint right here, and I told you the whole length was 18, you should know it's 9 and 9. Or if I told you that one of these small lengths is 19, then you should know this length is 19 and the whole length would be 38. Find the coordinates of the midpoint. Know the midpoint formula. If I give you 2 ordered pairs, you should know how to use this formula. X plus x divided by 2, y plus y divided by 2. So we looked at that yesterday. Number 3, when given an angle with an angle bisector like this, be able to find the measurement of the big angle or the smaller angle. For example, if I told you this whole angle was 80 degrees, then you would know the 2 smaller angles were 40 and 40. If I told you this small little angle right here was 50 degrees, and this is an angle bisector, then you should know this is 50, and you should know the whole angle is 100 degrees. Number 4, when given an angle, be able to find its complement and supplement. If I told you an angle is 40, the complement of that would be 50. They add up to 90. The supplement of that would be 140 because they add up to 180. Number 5, remember that a straight line is a straight angle that measures 180 degrees like this. Also remember that when you have a straight line, no matter how many rays or lines are coming off of it, when you add up all of these angles right here, 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 and here, they're all going to add up to 180 degrees. We also looked at, excuse me, let me get a drink of water. This is going to be a long video. Okay, remember that vertical angles are congruent, so when two lines intersect, this angle and this angle are congruent, they're vertical angles, and this angle are congruent, they're vertical angles. Be able to rewrite a given statement as a conditional. Don't forget that a conditional statement is an if-then statement. I think the example we used yesterday was an apple a day keeps the doctor away, and we said if you eat an apple every day, then you will not have to see the doctor. That's called taking a statement and writing it in if-then form. Number 8, use the law of detachment to reach a conclusion. If E is between D and F, if this is true, then this is true. And then I state, well, guess what? E is definitely between D and F, so what conclusion can I draw? That DF equals DE plus EF. All right. Number 9, use the law of syllogism to write an if-then statement. If it's hot, May will go to the beach. If May goes to the beach, I will also go to the beach. So I'm going to write an if-then statement. Now think about, if it's hot, what do I know for sure? May will go to the beach. If May goes to the beach, what do I know for sure? I will go. So if it's hot, May's going to go, and if May goes, I'm going to go. So I can say, if it's hot, then I'm going to go. Then I'll go to the beach. Okay? And that's what we looked at yesterday. Today, we're actually going to look at Chapter 4 test. We're skipping Chapter 3. We're going to look at that tomorrow. There's a reason for that. I won't go into detail now. But if you got out Chapter 3 test, you might want to pause the video and get out your Chapter 4 test. If you don't have a Chapter 4 test, don't worry about it, okay? No big deal. You can just follow along and take some notes. Okay, here we go. Chapter 4 test review. Now, by the way, on Monday we reviewed Chapter 6. On Tuesday, Chapter 1. On Wednesday, Chapter 2. Today we're looking at Chapter 4. And on Friday we will look at Chapter 3. Chapter 3. Okay? Okay, let's review how to classify triangles by their sides. When dealing with sides, we have scalene triangles, we have isosceles triangles, and we have equilateral triangles. Okay? Now my job is not to teach you during this week. I'm reviewing stuff you should already know. Scalene triangles means none of the sides are congruent. Isosceles means I have two sides congruent, at least two sides. Equilateral means all three sides are congruent. So when I look at number 13, I can see right away that none of the sides are congruent. So based on the sides, I would classify this triangle as scalene. When I get to number 14, I notice that all three sides are congruent, so I would classify this triangle based on its side by calling it an equilateral triangle. Now when I get to 15, I notice that again all three sides are different, so I would call this a scalene triangle. Now by the way, if I would have said this 14 here is a 16 and then I would have had two sides congruent, then I would call this triangle based on its sides an isosceles triangle. Okay, so be able to classify triangles by their sides. Let me get a drink of water here. Be familiar with these three terms and their definitions. Okay, moving on. Let's review how to classify triangles by their angles. We have right triangles, we have obtuse triangles, we have acute triangles, and we have equiangular triangles. Now, a right triangle means we have one angle that's 90 degrees. An obtuse triangle means we have one angle that's larger than 90. An acute triangle means that all three angles are less than 90. And an equiangular triangle means all three angles are congruent. So let's look at number 6. Number 6 has all three angles congruent. So we know we have an equiangular triangle. And by the way, if you wanted to be picky, you could also call this an acute triangle, because if this triangle is equiangular, that means all three angles have to be 60 because they have to add up to 180. So really you also have an acute triangle. So I would accept either one of those two answers. Okay, number 17, notice one of your angles is over 90. So right away I know that I have an obtuse triangle, because the definition of an obtuse triangle is one angle is larger than 90. Now, some of you might look at this triangle here and say, oh, look, a right angle. Okay, you're just going by the naked eye there. You can't assume that, okay? We know this angle is 70 and this angle is 25. So if you add those two angles together, you get 95. Well, you know that all three angles have to add up to 180, so that means this angle right here has to be 85 degrees, because 85 plus 95 is 180. In other words, 85 plus 70 plus 25 is 180. So we don't have a 90-degree angle here, folks, okay? Every angle is less than 90, we have an acute triangle. Okay? The definition of an acute triangle is when all three angles are less than 90. So the only triangle not given here as an example would be a right triangle, and a right triangle would look like this. You would want to look for that right angle symbol, okay? Or maybe on the test, on the exam, I'll give you an angle of 30 here and an angle of 60 here. And of course, if this is 30 and this is 60, add them together, you get a 90. So this has to be 90 also. Either way, you'll know that you have a right triangle if one of your angles is 90 degrees, okay? So on the exam, make sure you are familiar with these four terms and their definitions. Be able to classify triangles based on their what? Angles. Okay, let's continue on. Find the measure of angle 1. Let's review that the sum of the three angles inside of a triangle is 180. Let's review that the exterior angle is equal to the two remote interior angles. And let's review that when two sides of a triangle are congruent, their opposite angles are congruent. Now we'll get to all that in a second. Let's start over here. First of all, you know that all three angles inside of a triangle have to add up to 180. So if I take 28 plus 73, I get 101 degrees. Then if I take 180 and I subtract 101 degrees, I'm left with 79. So this angle right here, angle number 1, has to be 79 degrees. Okay, all three angles inside of a triangle have to add up to 180. Okay, let's review now about exterior angles of a triangle. Notice I extended one side of this triangle and one side only. When you extend one side of a triangle and one side only, you get what we call an exterior angle. And this is my exterior angle. Now, here's what you need to remember. The exterior angle of a triangle is always equal to the sum of the two remote interior angles. See this angle right next to 132? We'll put a little mark right here. See that angle right here? That angle has nothing to do with the problem right now, okay? What we're saying is an exterior angle, 132 degrees, this exterior angle right here, is equal to the sum of these two angles right here. So in other words, when I take 57 plus this angle here, I should get 132. So I'm going to take 132 and I'm going to subtract 57 degrees. And I'm going to get 75 degrees. Alright, so I know that this angle up here has to be 75 degrees, because 75 plus 57 gives me 132. So what we're reviewing there is simply this. We're reviewing that an exterior angle of a triangle equals the sum of these two remote, far away interior angles over here. Okay? Alright, now let's take a look at number 21. Here's what we're reviewing. Whenever a triangle has two congruent sides, like this side here is congruent to this side here, you can draw arrows to the angles opposite, draw an angle over here, and draw an angle over here, and these two angles are congruent right here. So whenever, let me go over that again, whenever two sides of a triangle are congruent, like these two sides here are, then their opposite angles are always going to be congruent. So this angle here is congruent to this angle here. Okay? So that's something you need to know. Again, for the third time, when two sides of a triangle are congruent, their opposite angles are congruent. Now, Do you see how I have a straight line right here? You should see that. See how I have one line coming off of it? We looked at this yesterday. Whenever you have a straight line with one ray coming off of it, that means these two angles right here, this angle here, and this angle right here, they're going to add up to 180 degrees. So that means this angle right here has to be 55 degrees, because 125 plus 55 equals 180. Now, if this angle here is 55 degrees, did we not just learn a second ago that these two angles are congruent? Whenever two sides of a triangle are congruent, their opposite angles are congruent. So if this is 55 degrees, then I know this is 55 degrees. Now, if I know that, and I know that all three angles inside of this triangle have to add up to 180, I can take 55 plus 55, and I can get 110. And then I take 180 and I subtract out the 110 degrees, and I'm left with 70 degrees. So this angle right here, angle 1, is 70 degrees, because 70 plus 55 plus 55 equals 180. So we reviewed three things. We reviewed the three angles inside of a triangle add up to 180. We reviewed that the exterior angle of a triangle is equal to the sum of the two interior angles. And we reviewed that whenever two sides of a triangle are congruent, their opposite angles are congruent. Now let's continue on. We're going to apply that same principle here to number 22. Let's review again that when two sides of a triangle are congruent, their opposite angles are congruent. So if this side here is congruent to this side here, I can then go across to their opposite angles and mark them congruent. So this angle right here is congruent to this angle here. So if this angle is called 2x, then I can call this angle 2x. Now the directions say to find the value of x. So I know all three angles here. I know I have 2x plus 2x plus 6x. I know if I add up all three of those angles, I will get 180 degrees. So now I'm ready to solve this. 2 plus 2 plus 6 would be 10x equals 180. Let's divide both sides by 10, and x equals 18. That was pretty simple. I mean, once I realized that when two sides of a triangle are congruent, their opposite angles are congruent, then I could set this up pretty nicely. 2x plus 2x plus 6x equals 180, and then solve. But now let's learn a new property. Well, not new, but let's review an old property that's the opposite of this. I've been saying that when two sides of a triangle are congruent, their opposite angles are congruent. Well, now I'm going to say the opposite. It is also true, and we learned this earlier this year, when two angles are congruent, their opposite sides are congruent. So this angle here is congruent to this angle here. So if I go to the opposite side of this angle, which is that side, and if I go to the opposite side of this angle, which is that side, these two sides will be congruent. How do I know that? Well, let me say it again. I know that because whenever two angles of a triangle are congruent, then their opposite sides are congruent. So I know for sure that my 30 is going to equal my x plus 12. They're congruent. This side right here is congruent to this side right here. In fact, I'm going to go ahead and put a slash right here and a slash right here. Now, let's go ahead and solve for x. 30 equals x plus 12. I'm going to bring my positive 12 over and make it a negative 12. And when I do, this positive 12 is gone. 30 minus 12 is 18, and 18 equals x. So there we go. I just found the value of x, 18. It's a coincidence, of course, that both answers are 18. So let's review again. When two sides are congruent in a triangle, their opposite angles are congruent. And when two angles are congruent, their opposite sides are congruent. Let me get a drink of water here. And we will continue on. Okay, let's take a look at the next page. Okay, let's review Pythagoras Theorem. L squared plus L squared equals H squared. Now, anytime that you have a right triangle like we do here and here, anytime you have a right triangle and you know two sides, you can find the third side by using Pythagoras Theorem. So let's do that very quickly. Notice I have a leg right here, this is a leg right here, and this is my hypotenuse right here. So using this formula right here, Pythagoras Theorem, I have a 4, that's a leg, so 4 squared, plus another leg that's squared, that's 5 squared, equals my hypotenuse squared, which is x squared. Well, 4 times 4 is 16, 5 times 5 is 25, equals x squared. Add these two numbers together, 41 equals x squared. Now, I'm not interested in knowing what x squared is. I want to get x all by itself. So in order to make x squared become just x, I'm going to take the square root of x squared. But you cannot take the square root of one side unless you take the square root of the other side. So the square root of x squared is x, and the square root of 41 is just 41. Now you're welcome to leave your answer like that, or if you want to type into your calculator the square root of 41, that's fine. You will get 6.4. 6.4. Okay, now let's go ahead and use Pythagoras Theorem over here on this triangle. This is a leg, this is the hypotenuse, and this is a leg. So I have leg squared, so one of my legs is an x, my other leg is an 8, so 8 squared equals hypotenuse squared, 17 squared. So next I would have x squared plus 64 equals, and then 17 squared, which would give us 289. 289. All right. Now let's bring the 64 over, and when we do, it's gone, and it's going to become a negative 64. So I'm left with x squared equals 225. 225. Now, I'm going to take the square root of 225, and if I do that correctly, well, first of all, I want to make the x squared become an x, so I take the square root of x squared. But you cannot take the square root of one side unless you take the square root of the other side. The square root of x squared is x, and the square root of 225 is 15. 15. So the answer to number 25 is 15. Okay, so what we reviewed is when you have a right triangle and you know two sides, you can find the third side by using Pythagoras Theorem. L squared plus L squared equals H squared. Let me get a drink of water here. And we shall continue on. All right, find the distance between these 2 points. This is an x, this is a y, this is an x, and this is a y. Well, you need to know this distance formula for your test. It's the square root of this large formula, x minus x, quantity squared, plus y minus y, quantity squared. Well, let's start off with our x's first of all. 2 minus a negative 4. 2 minus a negative 4 squared, plus, and then we have y minus y squared. Negative 1 minus a negative 6. Negative 1 minus a negative 6. Now let's be really careful here. We would end up with 6 squared plus 5 squared. Okay, 2 minus a negative 4 is 6. Negative 1 minus a negative 6 would be 5. Now when you square the 6, you will get 36, and when you square the 5, you will get 25, and when you add those together, you will get 61. And the square root of 61 is 7.81. We'll just go ahead and say 7.8. Okay, so what you did, if you were to draw a coordinate plane, and if you were to plot these 2 points, like 2, negative 1 right here, and then negative 4, negative 6, you just found the distance between those 2 points, and the distance would be 7.8. So make sure you know how to find the distance between 2 points. Make sure you have this formula memorized. All right, number 27, we're going to classify the triangles as either acute, obtuse, or right. And notice all that we're given are the lengths of the 3 sides. That's all that we're given. So how in the world, if we're just given the lengths of the 3 sides, how in the world can we decide whether these triangles are acute or obtuse or right? Well, let me show you how. What we learned to do when I taught you this was to label the sides, longest side, LS, and then the shorter sides. Here's my shorter side and my shorter side, S and S, okay? And what I taught you to do was to take one of your shorter sides, square it, take your other shorter side, square it, add them together, and then compare that. I'm going to put a little blank here. Compare that to your longer side squared. Let me go over that again. We take your 2 shorter sides, you square them and add them together, and then you put a blank, and you're going to compare this side here with your longer side squared. We're going to see which side is larger. Well, if you square 10, you get a 100. If you square 12, you get 144. And of course, if you square 14, you're going to come up with 196. Put a little blank here. Add these 2 together, and we get 244 is blank when compared to 196. Well, of course, it's going to be what? Greater than. And I probably should get rid of that blank now, or it's going to look like greater than or equal to. So I'm going to get rid of that blank. So there we go. This left side here is greater than your right side over here. Or in other words, your 2 smaller sides, when you squared them and added them together, you got a larger number than when you squared your longer side. And anytime that happens, anytime this left side here is greater than the right side, when you set your problem up like this, that means you have an acute triangle. So you can take that to the bank and write that down. Even though you did not know any of the angles of the triangle, you can be assured you have an acute triangle. Okay, let's try that comparison over here and let's see what happens. Here's my longer side, here's my 2 shorter sides. So I'm going to take one of my short sides, square it, and add to it my other shorter side squared. Now I'm going to put a blank, and I'm going to square my longer side. Now let's see what happens. 7 times 7 is 49. 9 times 9 is 81. Put a blank. 12 times 12 is 144. Now let's add these 2 numbers together, and we get 130 blank compared to 144. Well, obviously 130 is less than 144. Okay, so now what happens? Well, anytime that you set your problem up like this, with your 2 shorter sides over here being squared and added together, and your longer side to the right being squared, anytime you get out that the left side is less than the right side, then you know that you have an obtuse triangle. Okay? So Mr. Earhart, I see when we get out an acute triangle. I see how we know when we have an obtuse triangle. What about a right triangle? Well, if you would have worked this whole side out and you would have gotten 144 equals 144, then that means you have a right triangle. Or if you would have got over here 244 equals 244, the 2 numbers are equal, then you know you would have a right triangle. So when you have these 2 numbers coming out to be the same, then you know you have a right triangle. But other than that, when the left side is greater than the right side, you know you have an acute triangle. And when the left side is smaller than the right side, you know that you have an obtuse triangle, as long as you set your problem up like this. Your 2 shorter sides here being squared and added together, and your longer side over here being squared. So that's a really good review of how to look at just the sides of triangles. And using these formulas here, or these tests, you can decide whether the triangle is acute, obtuse, or right. Okay, I want you to list the angles from smallest to largest. And you say, well, Mr. Earhart, there's no way to do that. We don't know any of the angles. True, but we did learn something in this chapter. We learned that the smallest angle is always across from the smallest side. So if I want you to list the angles from smallest to largest, I find the smallest side, which is the side here, and I go straight across, and that's angle A. So if 5 is my shortest side, then angle A is my smallest angle. Okay? Now, after side 5, what's my next smallest side? Well, it's not 7, it's 6. So I draw a circle around that, go straight across, and it looks like angle B is going to be my next smallest angle. And then my only angle left, of course, is across from side 7, and that's going to be angle C. So there, you did it. You listed the angles in this triangle from smallest to largest, okay? Because you knew that the smallest angle was across from the shortest side, and so because of that, you could then figure this out. Now let's do the opposite. Let me grab a quick drink of water here. Now I want you to learn to list the sides from the longest to the shortest. Now you might say, well, Mr. Earhart, that's impossible. We don't know the lengths of any of these sides. True, but we know that the longest side is across from the largest angle. So if I'm going to list the sides from the longest to the shortest, I'm going to find the biggest angle, which is right here. Well, and by the way, I better put some names up here. Let's call this A, B, and C. That's my fault. Okay, here's the largest angle, so we go straight across. And what side is right across from angle B? Side AC. So I know for sure that, what in the world? Here we go. A, B, C. I know that the longest side is AC. Okay, cross this angle off. Now what's the next biggest angle? Well, it's not 42, it's 52, and then we go straight across, so we know AB is the next longest side. So AB. Cross off this. And then the only angle left, my smallest angle up here, is angle 42, so I go straight across, and I'm left with side BC. So there we go. We listed out the sides from longest to shortest. Pretty cool, by just looking at the angles and realizing the longest side is across from the largest angle. And then last but not least, I want to review what the centroid of a triangle is, okay? Now here's the deal. Watch carefully. What I'm about ready to say, you do not need to know for the test, but just listen. Anytime you draw a line from the vertex to the other side so that it forms a right angle, and then draw another line from another vertex all the way across the triangle so that it forms a right angle, and then when you draw another line from the vertex of the other, or from the vertex of the third vertex so that it forms a right angle over here, these three lines are always going to intersect in one place, and that one place right there is called the centroid. Okay, so that's what the centroid is. Having that in mind, one thing I should have put in the directions is, and I'm going to do that now, P is the centroid of these triangles. Now, when that happens, please listen to me carefully. Do you see this line right here? This longer segment right here will always be twice as big as this segment here. Got it? And see this segment right here? This whole line right here? Well, this bigger segment from here to here will always be twice as big as the segment from here to here. Okay? And then I think the other line I didn't use was, I forget actually, I think it was this one here. Well, anyways, on this line right here, this longer segment right here will be twice as big as this segment here, and that's always true when this is the centroid right here. Okay, so with that in mind, here we go. Let's get started. I'm telling you that KN is 24. So this whole line right here is 24. Now think about that for a second. I'm going to take 24 and divide it by 3. Now watch what happens when I divide it by 3. That means I'm dividing 24 up into 3 things. 8, 8, and 8, right? Let's talk about this again. I know the length of this whole line is how long? 24, so I'm going to divide it by 3. Do you always divide it by 3, Mr. Earhart? Always. Always, always. Divide it by 3 and you get 8. Well, that means you have 8, 8, and 8. So that means this little segment here is 8, and this longer segment is twice as big, so that's going to be 16. There we go. So, and we know that's right because 8, let me say that again. We know this is right because 16 is twice as big as 8, like it's supposed to be. This segment right here is supposed to be twice as big as this segment. And we also know if we add 16 plus 8, we get 24. So we're good. So KP is 16 and PN is 8. Not too bad. Now let's try the same thing over here, only this time realize I'm giving you the length of PM. So see PM goes from here to here. Do you see that? There's PM. And I'm telling you PM is 7. This little segment right here is 7. Okay? Now, if this segment right here is 7, then what I have to remember is what I've taught you is this little segment here, when compared to this big segment over here, this big segment is always twice as big as this segment here. So this segment here is 14, JP is 14, and PM is 7. JP is 14, and PM is 7. Because this longer segment here is always going to be twice as big as this little segment over here. So now let's see if I can't answer these questions. How long is JP? Well, it's 14. I just said that a second ago. And how long is JM? Well, the whole segment is 14 plus 7, so it's 21. Okay? So there we go. Now, about 5 minutes ago or 3 minutes ago, I did make a little mistake, and I apologize, and I want to quickly go over this again. Something I said that was incorrect, and I'm sorry. Sometimes I get going and I just throw things out, and I get things confused like anybody else does. A second ago, I said that the centroid is when you draw a line from a vertex across a triangle like this so that it forms a right angle, and that is not true. I'm sorry, that is not right. It's when you draw a line from the vertex across so that it hits the midpoint of this opposite side. And then you do that from this vertex over to this midpoint, and then you draw a line from this vertex down to this midpoint. Whenever you do that, it has nothing to do with forming a right angle, and I apologize, that's not correct. Whenever you do that, these three lines will always intersect at one place, okay? And so I'm going to show you very quickly what I'm talking about, and then I'll be finished. If I were to draw a triangle like this, there we go. There we go. And then draw a line from the vertex over to where I think the midpoint would be, which looks like it's about right there. That's pretty decent. And then draw a line from the vertex over to the middle, which I think the middle would be about right there. So I'm going to draw it there and go straight over. That's okay. And then I'm going to go from the midpoint here over to that vertex. Those three lines will nail at one intersection place right here, and that point right there is called the centroid. Okay, so I did misspeak. I misspoke earlier when I said it has to form a right angle. It does not have to form a right angle. It has to hit right at the midpoint. Now, I'm not testing you on that anyway, so you're fine there. The main thing you need to know, students, is this: you need to know that whenever you have a centroid, these lines right here can be broken up in such a way that this segment here is twice as big as this segment here. I hope this review has been a help to you. If you have any questions, don't hesitate to call me or email, and I will talk to you guys tomorrow.